So let's start talking about field devices. So in our world, we have RTUs, PLCs, and flow computers. So one of the things I do, and probably not a lot of you can answer this question, but this is some photographs of a bunch of different manufacturers' equipment. I'll ask the question, which one is the RTU, which one is the EFM, which one is the PLC? Anybody got any guesses? All of them? All of them are all of them? They're all RTUs? Well, okay. This is actually an Allen Bradley PLC, right? Here's the deal. These devices, over time, RTUs have become more capable and look more like PLCs, and PLCs have become smaller and more configurable and look more like RTUs. But there are some dividing lines. Why would it matter for when we're saying I need a PLC, I need an EFM, I need an RTU? Why would it matter that we're all talking about the same thing? Okay, so, well, it has to do with the application, but here's the thing. Just kind of a clue, if you say money, you have about an 80% chance of being right to any question I ask, right? Because these guys do different things and they have different price points, right? So that's why it matters. All right, so RTUs historically are dumb. So again, going back to the railroad analogy. So the first thing that started happening is people wanted to use phone lines or phone communications, modems, to move the data, right? Rather than having to have a pair of copper on every signal, right? And a big old cable like this. They want to use phone lines. To do that, they built RTUs. RTUs are an old technology. They've been around since the 50s. They were transistors. They were historically dumb. They had a little bit of memory. They stored something in an 8-bit memory block, and I read the bytes out of that, and then in the host I interpreted them, right? So RTUs are historically dumb. They're generally managed or built, manufactured for a very specific purpose, right? So RTUs are not very configurable. They're kind of pull them out of the box, hook them up, turn them on, and they just work. It's kind of my definition of an RTU. They're also optimized for environmental conditions, you know, in a wide range. I can put it on the Arctic shelf, I can put it in the Sahara Desert, it's gonna be fine. I don't need any dust control or temperature control or any of that kind of stuff, right? So they're very robust, they're hardened. They're also low power, but they generally have proprietary firmware and proprietary communications, meaning that the chip that's on the RTU is custom coded, right, for a specific purpose. Now, why would that be important? Why would we build RTUs that way? Okay, remember what I said earlier about the answer that's, you say it, money, right. So if I've got an oil field and I need to buy 1,000 pump-off controllers, does $50 a pump-off controller matter to me? In my experience as a vendor, yes, it matters to you guys. And sometimes it matters a lot, right? Because $50 times a large number becomes a large number, right? So RTUs can be optimized to be very low cost, but there's a trade-off between what I can do with them and what they cost to put in. All right. And historically, RTUs were only serial communications, and really in the last 5 years, that's changed. They all pretty much support IP these days. All right. So they're designed for low power, low bandwidth, low maintenance. You don't really program an RTU, you configure it, okay? So the level of skill that you need to deploy it is less than something that needs to be programmed. All right, so this is a diagram of a kind of a typical architecture of an RTU. And again, it's older, right? You know, if you look at newer stuff, it's not going to look quite like this. But what you've got is a power supply, you've got a chipset, you've got volatile and non-volatile memory. Volatile memory is memory that gets flushed when the power goes out. Non-volatile memory is memory that stays when the power goes out. So most RTUs, PLCs in this day don't have any non-volatile memory other than the basic firmware chip. Reason we do that is I don't want to have to go out to the site to change a chip out. I want to be able to do that across the telemetry. So what they'll do is they'll put batteries, you know, small lithium batteries in there, and they'll have something that looks like non-volatile memory, but really it's backed up by battery. That's why some devices, if you buy it and configure it and set it on the shelf, and 6 months later you need to take it out to the field, it lost its programming. Because, you know, those batteries will work for months, but not forever. Okay, so the other thing is we've got custom boards for each of the various kinds of signals that I need to process. So, analog versus digital. Analog is a signal that scales 0 to 100%, right? And it's typically done electrically based on amperage or voltage. So I modulate amperage or voltage, and that correlates to an output. So if I get a pressure, you know, if I get a pressure transmitter and I'm modulating the pressure, the internals are converting that to an electrical output proportional to the range of that transmitter. With digitals, it's simply like a light switch, off or on. An input is I'm reading it, an output is I'm writing it or driving it, right? So I use an analog out to send a signal to something like a flow controller or a valve that's, you know, regulator, a valve that's got a positioner in it. I'll send an electrical signal and the positioner moves, proportional to the electrical signal, all right? So all of this is pretty simple. Typically RTUs have limited communications ports. Again, I'm trying to get it to do a job, and I'm trying to get it to do that job at the lowest price point possible.